So instead of expanding logarithms, let's go the other way and let's try to condense and write as a single logarithm. For example, if I were to write 7 times the log of w, how do I kind of put this all back into one nice, tidy little package?
Log of w is 7.
Right, so we put the power, instead of having the coefficient out here, it goes back as a power of what's on the inside here, so log of w to the 7th. Okay. If I say 3 times the natural log of a plus 8 times the natural log of b, can you write this as a single natural log? Now, we would have been in trouble if one of these had been log, common log, and the other were something else, natural log. As long as these guys are the same type of logarithms, you can condense them into one. So how are we going to rewrite this 3 natural log of a?
A to the third.
So inside here it's going to be a to the third.
Times.
Right, so this addition of logs becomes multiplication on the inside of what? B to the 8th power. That's what it means to rewrite as a single logarithm. That's just using the properties of logarithms that we talked about last week. So if I say 5 log of x minus 4 log of y minus 6 log of z. How do we write this as a single logarithm?
Log.
So we're going to have a single log, and what's inside of it? X to the 5th, but I've got these negative guys here, right? The negative ones are going to indicate that I have what on the inside? The fraction. They're going to be in the denominator, right? So in the numerator I have, well, this is the only guy that has a positive coefficient, so he's the only guy in the numerator, so it's x to the 5th power. And what about these guys?
Y to the 4th.
Y to the 4th in the denominator, and z to the 6th, which is also in the denominator.
So how do you know which one goes in the denominator?
The ones with the negative coefficients, because the negative coefficients correspond to negative powers. So you could have rewritten this, and you could have said, you know what, I'm just going to put it all together and say log of x to the 5th times y to the negative 4th power times z to the negative 6th. But then you run into this issue of these guys have negative powers, so where do they go? You put them in the denominator, just properties of exponents at that point. Yes, question?
Just about the parentheses after the logs, like on the x, y, and z, how necessary is it, or do you put?
How necessary are these parentheses?
Very.
Well, you could probably get away without writing them. I tend to write parentheses like this, or even for these other examples, just to avoid any kind of questions, confusions, ambiguity, because this one right here, if I don't have the parentheses, there's that question of, okay, is the power of 7 on the w? Is the power of 7 on the entire logarithm? And so if I do it like this, there's no question about where the power is. And here, I like having those parentheses because to me, it just creates this nice closure for that problem, that I can clearly see what is contained inside the logarithm. Not that I'm afraid they're wild animals and they're going to escape and run around to other parts of other problems, but here, I don't know, having things like a good little cage. Not that things need to be caged. I should probably stop.